Good morning, students. I welcome you for the chemistry class. And in this particular video, let us discuss 10 questions from your text. So, this is all your textual question. So, you can have a look, understand, and make a note of that. First one, why should a Mg ribbon should be cleaned before burning in air? Mg, it's a very reactive element which rapidly reacts with oxygen in the air to form a layer, a white layer that is magnesium oxide. And this layer will not burn easily. So to make Mg ribbon to burn more easily, we have to remove this layer and then only that Mg ribbon can burn easily. Along with that, there is a formation of basic magnesium carbonate. This was discussed in online class. So make a note of that also. There is a formation of basic magnesium carbonate layer, that is MgCO3 dot MgOH twice. So this layer is also seen which will interrupt. It acts as the impurities. Unless this impurities is removed, Mg ribbon cannot be burnt easily. Second question. What precaution should be taken while burning Mg ribbon? We have to wear eyeglasses because Mg burns with a dazzling white fumes, and you can see there is light energy as well as heat energy which is evolved, and that can cause temporary loss of vision. So because of that you have to wear eyeglasses and use tongs and burn Mg ribbon keeping it away. As I said, dazzling white fumes, it can cause temporary vision, loss of vision, as well as enormous amount of heat is also liberated. So because of that, be safe so that you can ignite little bit far. And clean the ribbon before burning. Clean the sense you have to clean it with a sandpaper, rub with a sandpaper. Next, what kind of reaction is burning of Mg? You are saying you are igniting, where igniting in the sense it starts reacting with oxygen. So you have a confusion where you are supplying heat also. You are just initiating the reaction. Actually, a little bit of heat is required to initiate the reaction. That's it. If I keep Mg ribbon as it is, it can react with oxygen, so there's a formation of layer. But to show it in the lab, I have to supply an extra energy that in the form of burning. So when I burn in the sense it is understood, it will react with oxygen. So when it burns in the sense Mg is reacting with oxygen, so formation of magnesium oxide, a powder, a white powder is obtained immediately. That is MgO. So enormous amount of heat is liberated. So always burning of Mg, there is a combination reaction and it is exothermic in nature. Next, what is chemical equation? It's a representation of a chemical reaction by using symbols and formulas. So it is the example 2H2 plus O2 giving rise to 2H2O. So this by using symbols and formula is called chemical equation. What is skeletal equation? Skeletal equation, it's an unbalanced equation where the mass on both the sides are not equal. So you can see over here H2 plus O2 giving rise to H2O. Hydrogen is balanced but there is no balance of oxygen atom. So it is skeletal equation. What is balanced equation? Why should chemical equation should be balanced? A balanced chemical equation where equal number of atoms of each element involved in a reaction is represented on reactant side and product side. So equal number of atoms of each element should be present on both the sides. For example, 2H2 plus O2 giving rise to 2H2O. So there is a balance on both the sides. There is 4, there is hydrogen is 4, oxygen is 2, oxygen is 2. When I write 2 over here, it is applicable for oxygen also. And why should a chemical equation should be balanced? Because to satisfy the law of conservation of mass, where matter can neither be created nor be destroyed. Next, fifth question. Translate the following statements. I have not given a statement here because it's in your text. So follow your text. The first statement is hydrogen reacting with nitrogen to form ammonia. So hydrogen 3H2 plus N2 giving rise to 2NH3. Next, hydrogen sulfide burns with oxygen. So when it burns with oxygen, since it reacts with oxygen, to give water, sulfur dioxide. Third one, barium chloride reacting with aluminium sulfate giving aluminium chloride and barium sulfate. So it should be, you are well versed based on their ions. Okay, barium is +2, Cl is -1. When you crisscross, formula will be BaCl2. Aluminium is +3, sulfate is -2. When you crisscross, formula will be Al2SO4 thrice. So you should be knowing the basics, what you have learned in ninth standard, where writing of formulas, it's very important for this particular chapter. Then potassium is added to water. So potassium reacting with water to give potassium hydroxide and with the liberation of hydrogen gas. Next, sixth question, balance the following chemical equation. So this is the equation which is in your text. Four equations are there. So I have given a balanced equation here. HNO3, nitric acid reacting with calcium hydroxide, giving calcium nitrate and water. So you have to suffix 2, coefficient over here, and here it is 2. Sodium hydroxide reacting with sulfuric acid. You get sodium sulfate plus water. So again, Na2 is there, whereas only Na is there. So suffix 2. Okay. Then NaCl with AgNO3 giving rise to AgCl and NaNO3. When you see this, the equation is already balanced. So they have given a balanced equation and they have told to find out whether it's a balanced chemical equation. So it is fine. This equation is already balanced. Then fourth one, barium chloride reacting with sulfuric acid to give barium sulfate and HCl. So you can see chlorine is 2, but here it is only 1. So how to make it 2? I cannot change the formula. In front of the box, what I can do? I can add 2. So when you add 2, it will become balanced. Then write the balanced chemical equation. So all the word equation is there in your text. Question number 7. So follow that. Calcium hydroxide reacting with carbon dioxide to give calcium carbonate and water. Second one, zinc reacting with silver nitrate to give zinc nitrate and silver. Then third one, aluminium reacting with copper chloride giving rise to aluminium chloride and copper. Fourth one, barium chloride reacting with potassium sulfate giving rise to barium sulfate and potassium chloride. So learn those oxidation number, valency, crisscross and find out the formula. By this you can know Zn is +2, NO3 will be -1. So when you crisscross you get Zn NO3 twice. So learn the basics of your previous class. Next, question number 8. So they have given 4 reactions where you have to find out what type of reaction it is. Okay. Potassium bromide reacting with barium iodide. So barium will be +2, iodine will be -1. So you get BaI2, barium iodide, giving rise to potassium iodide and barium bromide. So what type of reaction? You can see there's a mutual exchange of ions which is taking place. So it is double displacement. In double displacement, it is precipitation reaction. So whenever a precipitation reaction is happening, so what's the indication? You have to write a downward arrow mark. Then ZnCO3. When you heat it, you get ZnO and CO2. When you heat in the sense, it is endothermic reactions, right? So it is decomposition. One compound is splitting into 2. Then H2 plus Cl2 giving rise to 2HCl. So two things are combining. Here two elements are combining to form a compound. So combining, so it is combination. Then Mg plus 2HCl giving rise to MgCl2 plus H2. So what has been displaced? Magnesium being highly reactive, it is displacing hydrogen. So it is a displacement reaction. You have to write a balanced equation and then write down what type of reaction it is. Coming to the ninth question. What does one mean exothermic and endothermic reaction? Give examples. A reaction in which heat is evolved is called exothermic. For example, burning of fuel, a combustion reaction. So C plus O2 giving rise to CO2 plus heat. So you can write delta symbol also. The reaction in which heat is absorbed is called endothermic reactions. So N2, nitrogen reacting with oxygen. So at what temperature? 3000 degrees you get nitric oxide. Next, why is respiration considered as an exothermic reaction? Because during this process, energy is liberated. When glucose combines with oxygen, you have to write this equation C6H12O6. Glucose combines with oxygen of air in the cell. So this is happening inside the cell. When it combines, it produces carbon dioxide, water, and energy is released. So this carbon dioxide is expelled out. Water is used by our body and energy is released that is used in our body. So this is why respiration is called exothermic reactions. So thank you. Let us discuss the textual questions in the next video. Until then, thank you. Have a nice day.